Properties of numbers. There are five properties of numbers that we're going to talk about today. The first property is called the commutative property. And the reason why we're taking notes is because it would probably be pretty hard for you to remember how to spell that on your own.
It is.
You have it in your notes. Commutative property. C-O-M-M-U-T-A-T-I-V-E. And the commutative property is that for both addition and multiplication, the order that you do them in does not matter. Okay? So what I mean by that is 5 plus 3 is the same as 3 plus 5. So that works for addition, 100%. Okay? Same thing with multiplication. If I go 5 times 3, that's the same as if I go 3 times 5.
So basically you're just turning it around?
Yeah, basically you're just turning it around. But what's important for you to understand... Hello. Are you good? Okay. All right. Kara? Okay. What's important for you to understand is that this does not work for subtraction and division. So if I change this to subtraction and said 5 minus 3, does 5 minus 3 equal 3 minus 5?
No.
No. Okay? Those two are not the same. How about 6 divided by 3? Does that equal 3 divided by 6?
Oh.
No. So the important thing is for you to understand which operations you can use that for and which ones you can't. So addition and multiplication, order doesn't matter. Subtraction and division, it does. Okay? All right, next one is a weird one. It's called the associative property. And this has to do with how you group your work. So if I have something in parentheses, like 7 plus 9, and then I have to add 1 onto that, if you think about what we just talked about with the commutative property and how the order of addition doesn't matter, can I add that up in a different way and still get the same answer?
Sure.
How can I do it a different way? Ben? Okay, good. So I could change the parentheses to be around the 9 plus 1 instead, and I'll still end up with the same answer. Okay? And that's called the associative property, and that's because you can associate them in different ways. And this is a very handy thing that you probably use all the time. If I had to add up the numbers 7 and 9 and 1, which are the easiest of those two numbers to add together first? The 9 and the 1, because that gives you 10, right? And then 10 plus 7 is 17. Whereas 9 plus 7, you might have to think about that one a little bit. So when you're doing an addition problem, you can decide which pairs you want to put together first. And so I coach golf, and if we have a 9-hole tournament like we're going to have today, and the kid comes in with his scorecard and it looks like this, I don't know, and he says, what did I shoot? I'm not very good at math. When I look at their scorecards, I go 5, 10, 15, 20. And then that's another 10, so that's 30. There's another 10, so that's 40. And then this one left over makes 44. Okay? And they all, no, 44 would be good. And they all think, you know, oh, you're so good at math and you're really smart. But all I'm doing is I'm using the associative property to add them together in a way that makes it easier for me to do the math. Okay? And then you can also do that with multiplication. So if I wanted to figure out what 4 times 2 times 5 was, what might be a little bit easier than multiplying the 4 times the 2 first? What two of those three numbers can I multiply together to get a nice, easy number to work with, Blaine?
5 times 2.
Yeah, 5 times 2 is 10, and then 4 times 10 is 40. So it might be easier for me to group that problem like that instead, okay?
Well, like if you're doing a math problem, or you have to do parentheses first?
Yeah, and so what I'm telling you is that there's kind of ways that you can break that law a little bit.
So
Okay.
by just switching it around.
As long as it's addition or multiplication, then you can switch it around a little bit. Okay, again, subtraction and division, you're going to have some issues with. Okay? All right, so those are ones that we just sort of use without even thinking about it. Okay? And this one, how many of you have ever heard of the distributive property? Raise your hand. Okay, about maybe 3/4 of you or so. Okay, the distributive property is a very important one, because this helps us with the case where you cannot do what's inside parentheses first. So let's say that I asked you to multiply 3 times 4 plus a. Can I add 4 and a together if I don't know what the a stands for?
No.
No, okay, because one's a letter and one's a number and one's a variable, okay? And so the way I get myself out of this little trick is by using the distributive property, okay? So I'm going to multiply both of these things inside the parentheses by what's outside the parentheses. So 3 times 4 is 12, so I multiply those together and get 12. And then 3 times a, how do I write that? Is 3a. And what is the math operation that I would put in between the 12 and the 3a in this case? Nope, because I did the multiplication. Plus, right, since this is an addition here, I'm going to put an addition there, okay? So that gives me a way to simplify a problem when I have parentheses, but I can't do what's inside of those parentheses first. I can distribute that 3 and get rid of those parentheses, and now if I get a value for a, I can just plug it in there, multiply by 3, add 12, and I'm all good, okay? So the distributive property is very important. We're going to use that a lot in this class. Okay, 2 more that are kind of silly. You know these already. I don't know why we have to name them, but I didn't write the book. One is the identity property. When you are adding, what can you add onto something and have your answer be identical to what you started with? Kara? 0. Okay, so the identity property for addition is 0. That 7 plus 0 is 7. Or you could just generalize this for any number. X plus 0 is not going to change that at all. It's still going to stay with as what you started with. Okay? And then there's also one for multiplication. What can I multiply a number by and end up with what I started with in the first place? Emily? 1. Okay? So if I put a 1 in here, 8 times 1 is still going to be 8. And again, we could do that with any number, so x times 1 is always just x. Okay? All right, and then the very last one is called the zero property. And this is also known as the Mr. Pugh property. If I counted the number of hairs on every person's head in this school and multiplied all those answers together, what would I get? Why? Because what? Because Mr. Pugh is bald, yes. And as soon as you get a 0 in there somewhere, it doesn't matter how big the number is that you're multiplying by 0. Anytime you multiply any number by 0, what are you going to get as the answer?
0.
0, okay? So that is the zero property of multiplication. And so that makes problems can make problems really easy for you to figure out if there's a 0 in there.
What's Mr. Pugh's hair color?
It's like a...
When he grows it out,
Yeah.
I think it's just kind of brownish, yeah.
That's cool.
That's cool. Okay, yeah, go golf. Okay.
Whoa. But when okay, so say that you put Mr. Pugh in the middle. So like, say there's like 5 million hairs, okay? And then we put Mr. Pugh, and then so that would go to 0.
Correct.
But then after Mr. Pugh.
Doesn't matter. Yeah, because it's still a 0, right? So even if I go, what did you say, 5 million hairs? Times 0, and then I go times another 5
What if you
million
add
here.
0, or what if you add like 6?
Okay, as soon as you get addition in there, then that's going to change the problem. But if I multiply them together, once there's a 0 in there, the entire thing is just going to be 0. Okay? All right, so let's take a look at these properties, just a couple quick examples. Is 3 times y times 5 the same as 15y?
Yes.
Why?
Because 3 times 5 is 15, so you can divide by
Okay, so what you're doing then is you're using the commutative property to switch those around, right? 3 times y times 5 is the same as 3 times 5 times y. And then 3 times 5 is obviously 15, and so we end up with 15y. Okay? So you, what's that? That's called the, what we use the commutative property to figure out if those are equal or not. Okay, so we switch the order of those around, and so we use the commutative property. So yes, they are the same. Okay? All right, how about this one? Is 4 times the sum of x plus 7 the same as, little question mark, we don't know, 4x plus 11? Why not? Don't know, just doesn't seem right? Just doesn't look right. Okay, Blaine?
Because using the distributive
Nice,
property,
distributive property.
4 times 7 is not the same as 4 times 11.
Okay, good. Remember that with the distributive property, you're going to multiply the whole way. Okay, so I'm going to go 4 times x, which is in fact 4x. So I've multiplied those two together. And then this plus sign stays there, but that does not mean that I go 4 plus 7. Since the 4 is outside the parentheses, it's multiplication all the way through, so I have to go 4 times 7, which is 28. So in this case, those two things are not the same. Okay? All right? So you can use the properties a little bit to tell whether things are equivalent or equal or not. All right? Okay, pretty sure that's the most fun you've ever had.
I did.
Let's.
What did you do?
Can we do a small assignment tonight?
Yeah, you can.
Thank you.
But it's not working.
Thank you.
Oh, you're now my favorite math teacher.